All right, guys, today we're going to learn how to do a ratio table. Everyone say hello to Fat Cat. She's kind of large. Big cat. Okay, so a ratio table. What we're going to do first is we're going to kind of talk about a problem and then see why a ratio table helps. Instead of just telling you why I think it's helpful, I'm going to show you why I think it's helpful. So this example says that a punch recipe uses 1 container of soda and 3 containers of juice to make a punch. So we're going to use a picture to show the above information for 2 batches. So I'm going to go back to my, let's pick your color. Let's pick green. Green's going to be my color today. So for 1 container of soda, so I have the letter S for soda, I need 1, 2, 3 juices. But I'm making a double, so I need to have this twice. So I have another container of soda and 3 more containers of juice. Okay, 1 picture done. Next, we're asked to show the ratio of soda to juice. And since the word soda comes first, soda goes on top. So I use 2 sodas for 1, 2, 3, 4, 5, 6 juices. Okay. Next, I would like me to show a picture for the 3 batches of punch. So I have 1 soda and 3 juices. And then I have another soda and 3 more juices. And then I have a 3rd soda and 3 more juices. So every time we increase the amount of punch, the ratio also increases, but it'll still reduce to the ratio of what? Well, my original one, way back in the beginning, was 1 to 3. Notice how I can see that here in the first example, I have 1 to 3 twice, which if you look here, I'm going to switch to blue now, I can divide both these by 2, which will reduce back to 1 to 3. So I can reduce the ratio to 1 to 3. Brings me to 2 definitions. First one is a ratio table. A ratio table is a table that is filled with equivalent ratios. And you're like, well, what's an equivalent ratio? That's a ratio that reduces to the same value. So for example, our 1/3 or our 1 to 3. They're created using multiples. We know the word multiple means getting bigger. So we get bigger, or technically, if I reduce them, then they'd be getting smaller. Okay, let's do an example. To make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? We're going to kind of make a little table. I'm going to pick my black color, and I'm going to say drops of coloring, 4 cups of icing. So it says that I need 6 drops for 1 cup. And then it wants me to find how much food coloring should you mix, so how many drops should you use with 5 cups of icing. And then I'm going to go to my blue. So from 1 to 5, remember we were using multiples, so I multiplied by 5, because 1 times 5 is 5. So to figure out the amount of drops, I need to keep that the same number and multiply by 5. So 6 times 5 is 30. So I need 30 drops. Fat Cat, your head's in my way. All right, Fat Cat, you're going to have to move. You're going to have to move, Fat Cat. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. So, again, we're going to start by making a little chart. So we had hot dogs come first. So hot dogs. Yep, not hots. So hot dogs and minutes. So he had about 66 hot dogs in 12 minutes. It wants to know if we ate at a constant rate, how many hot dogs for every 2 minutes. Okay, so in this time, we didn't go up, we went down. So I know typically multipliers we said are multiples, there we go, that's what. Multiples I said typically are going to get bigger. And you're correct, they can get bigger. Sometimes we're already at a larger multiple, so we need to go back down to what the original was. So what did I divide? Thinking, again, multiples go bigger with multiplication. So to a multiple to go smaller, we're going to do the opposite and divide. So 12 divided by what gives me 2? Well, if you're not sure, what is 12 divided by 2? And that should be my answer. Stop eating anything. Stop trying to eat stuff. So we divided by 6 here. So then I'm going to go ahead and take 66 divided by 6. 66 divided by 6 will give me 11. So he ate about 11 hot dogs every 2 minutes. Oh, I touched it. Stop. Stop. There we go. I don't know why my pen stopped being a pen, but it did. I can't hurt my nose now. That's very uncomfortable. All right, next one. To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Find the amount of sugar needed for 4 cups of cranberries. So I want sugar to cranberry. Forgot the R for a second. 12 for 16. Find the amount of sugar needed for 4 cups. So again, if you notice, I have gone down, so I'm going to end up dividing. And 16 divided by 4 is simply 4. So I'm going to take my 12 and I'm going to divide that by 4. 12 divided by 4 is 3, so 3 cups of sugar. Sorry, Fat Cat was trying to chew on a cord. Okay, try this one on your own. A patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours will it take for the patient to receive 4 liters of IV fluids? So 32 hours. Woo, another definition, scaling. Scaling is where you multiply or divide 2 related quantities by the same number. So pretty much what we've been doing this entire time, we just didn't have a definition or vocab word to associate it with. All right, cans of corn are on sale at 10 for $4. Find the cost of 15 cans. So it tells me the amount of cans. Oops, that needs to be in blue. Per the price, or the cost. So that means that I have 10 for $4. Well, I can't turn 10 into 15. I can go 10, 20, 30, nope, I've already passed it. But I can reduce down to my unit price by dividing both by 2 to start with, or at least getting close to. I know I can't take 10 divided by 4. But I can turn 5 cans into 15 cans. So I'm going to take that 5 cans for $2, and I'm going to multiply that by 3 because that's how I can get to that 15 cans. And when I do to one, I do to the other. So 2 times 3 is 6. So it'll cost $6 for 15 cans. On her vacation, Leah exchanged 50 American dollars and received 60 Canadian dollars. How many Canadian dollars would she receive for 20 American dollars? Okay, so again, we're going to start with which one came first. So American came first. Oh, that's really bad. Oh, now I have the booger. So for every 50 American, she got 60 Canadian. And I want to figure out 60 American. Well, I can't reduce 60 into... I'm sorry. My apologies. I looked at the wrong one. I cannot reduce my 50 into 20s, but I can reduce my 50 over 60. They both end in a 0, so I can cross it off. So I can say for every 5 American, she got 6 Canadian. Hey. So, that's the wrong number. 5 over 6 times something will give me 20 American over some amount of Canadian. No, I'm not playing with my pens. So what was that multiplier? What was that scalar? Well, 5 times 4 was 20, so therefore I have to do 4 in the denominator. So 6 times 4 is 24. So she'll get 24 Canadian dollars. All right, I want you to pause the video and figure out how many lawns he can mow. So he can mow 28 lawns in 49 hours. And that's all I have for you.